Hey students, so this is your quiz correction, so I'm going to go ahead and go through every problem step by step, show you how it was supposed to be done. You need to write this on your paper, only do the problems you need. Okay, so in this first one, this is a multiplication problem, and I think I actually graded this one wrong on the exam. Not that I marked any of you off, but I think I gave some of you points that had the wrong answer, and if that's the case, you can keep those points. That's my mistake. But we're just multiplying here, so negative 8 times negative 2 gives us a positive 16. And when I do square root of 5 times the square root of 5, I get 16 times the square root of 25. And we know the square root of 25 is actually just 5. And 16 times 5 is 80. So I believe some of you had this answer. And this answer I gave points for, but technically this is a wrong answer. Okay? Taking a look at problem number 2. You can break this up into two radicals, and this helps us because we know the square root of 49 is 7. We don't know the square root of 2, so this is where we have to rationalize the denominator. And we'll talk more about that in future lessons too, because it's pretty important. You multiply top and bottom by whatever you're trying to get rid of. And the reason we do this is because when you do square root of 2 times square root of 2, that becomes square root of 4, which is just 2. So what it does is it doubles the square root, which lets you get rid of the square root. Take a look at problem number 3. You needed to add and subtract here. So first we needed to simplify any of these that we could simplify. So a lot of us get stuck on this step. After we factor it out, we don't know what to do. Okay, so for example, the first one, sorry. The first one is 36 times 2. The second one is 9 times 7. And the third one is 9 times 4. Nope, 7 times 4, sorry. Okay, so a lot of us get stuck here. What you need to do is, these are being taken the square root of. They're still under the square root, we just factored them out. And we're still multiplying by whatever coefficient is in front. So here I have 4 times the square root of 36 times the square root of 2. We know the square root of 36 is 6, so I write 4 times 6 times the square root of 2 plus 11 times 3, because the square root of 9 is 3, square root of 7, minus 2 times 2, because the square root of 4 is 2, square root of 7. And so I end up with 24 square root of 2 plus 33 square root of 7 minus 4 square root of 7. So now I combine terms that are alike. Now in the case with radicals, they are alike if the radicals are the same. And so you would combine them the same way you would combine like variables. Is you combine the coefficients, the numbers in front, and you keep the radical the same. So I know I'm going to stay with 24 square root of 2, and I do 33 take away 4, which gives me a positive 29, and I keep the square root of 7. So that's the final answer you should have had for that problem. Number 4, this breaks down to 25 times 7. So I know I can take the square root of 25, that's 5, so you should be left with 5 square root of 7. Number 5, this is 49 times 5. So again, these are being taken the square root of. I know the square root of 49 is 7, so this becomes 2 times 7 times the square root of 5, which is 14 square root of 5. Number 6, I feel like 32 is one we worked with a lot. This is 16 times 2. Take the square root of 16, the square root of 2. We get 4 square root of 2. Number 7, this one could actually be simplified. If we think of the fraction 8 over 72. Okay, problem number 8. Here we can see that we're subtracting. We already have like radicals, so we don't need to do anything there. So we can just do 5 subtract 8, and that gives me 3 radical 12. Now a lot of you probably stopped here, but 12 can be simplified still. This is 4 times 3, so I know this is 3 times the square root of 4 times the square root of 3. And the square root of 4 is 2, so we get 3 times 2 times the square root of 3, which is 6 square root of 3. And that should have been the final answer for problem 8. Looking at problem 9, I know we didn't do too many of these, but it's the same process, it's just now you're distributing. So here we have the square root, 4 square root of 3, plus, when I multiply these two square roots, I get square root of 45. Now the square root of 45 can be broken down by 9 and 5, so I end up with 4 square root of 3, plus the square root of 9 is 3, and square root of 5 is left over. If you take a look at number 10, then we see we have 128, which is actually just 64 times 2. And so we have 8 times the square root of 64 times the square root of 2. So we have 8 times 8 times the square root of 2. And so coincidentally, we still end up with a 64 square root of 2. Sorry, if you hear weird noises, I have 2 dogs. Yeah, that's probably who you're hearing right now. Okay. For this one, there's a couple things I would do first. I'd want to simplify both of the fractions here. So I know 3, 6, those can both be divisible by 3. So I'm going to write that as 1/2. And then when I'm thinking about 15 over 80, I know both of these are divisible by 5. Specifically, I know it's 1 square root of 3. 5 goes into 15 3 times. And 2 square root of 16 because 5 goes into 80 16 times. And so this leaves me with square root of 3 in my numerator, and the square root of 16 becomes a 4, 2 times 4, and 2 times 4 gives me 8. So my final answer here would be square root of 3 over 8. Let's take a look at problem number 12. So I know the 8 can be broken down as 4 times 2. So we have 3 times the square root of 4 times the square root of 2. The square root of 4 is 2, so I get 3 times 2 square root of 2, which is 6 square root of 2. Okay, looking at the 125, this is 25 times 5. So I take the square root of 25 and the square root of 5. I know the square root of 25 is just 5, so I have negative 5 square root of 5. That's my dog Poop. She's coming over here right now. And then the next part we have is 32, which we already know is 16 times 2. And we take the square root of 16, the square root of 2. We know the square root of 16 is 4, so this becomes plus 4 square root of 2. And our last one is 45, which is 9 times 5. We take the square root of 9 and the square root of 5. The square root of 9 gives us 3, so we're left with 3 square root of 5. So our next step is to combine any pieces that are alike. We have 2 pieces. We have the square roots of 2. I have 6 of them and 4 of them, so altogether we have 10 square roots of 2. And then the other piece would be the square root of 5. I have negative 5 of them and positive 3 of them, so I'm left with negative 2 of them. And so this should be your final answer for problem number 12. Okay, taking a look at problem number 13. Here we are again multiplying and then combining, and we're multiplying by foiling, or you can use box method. So I do 2 times the square root of 6 times the square root of 6. So I get 2 square root of 6 square root of 6, which is 2 square root of 36, which is 2 times 6, which is 12. So that's the first term. Then I do square root of 6 times 8, and I get positive 8 square root of 6. Then I do negative 4 times 2 square root of 6, and that gives me a negative 8 square root of 6. And then I do negative 4 times 8, and that gives me a negative 32. So now in here in the middle, I have 8 radicals, and I'm taking away 8 radicals, so that cancels out to 0. So I can just bring down my negative 32, and I end up with negative 20. And that's our answer for problem 13. And let's take a look at problem 14. Determine if the three lengths could form a triangle. Use an inequality to prove your answer. So we said before that the two shortest lengths, when you add them, need to be larger than the third length. So if you take your first length and your second length, then they need to be larger than your third length, as long as these are the shortest. Okay, so I'm looking at my shortest here. I'm doing 14 plus 19. Well, that's 33. And I'm checking to see, is this larger than 31? If it is, then yes, this is a triangle. And 57, but it should not equal, you'll see there's no equal signs there, should not equal those numbers. So it can't be 51, and it can't be 57, and it can't be 58, because 58 is bigger than 57. So that means it can only be 53 and 55. And that is the answer I was looking for in your box, 53 and 55. Taking a look at problem number 16, it says compare the sides and angles by filling in the blank with the correct inequality. So when they say angle FJG, they're talking about this angle here. Okay, and when they say angle HJG, they're talking about this angle here. And we know already that the corresponding side to that angle is the side that it is across from. So if we want to compare these angles, we can actually just compare their sides, because their sides are relative to their angles. That means a smaller side is a smaller angle, a larger side is a larger angle. So in this case, FJG has a smaller side, so it has a smaller angle. Means FJG is less than HJG. Taking a look at number 17, they want us to order the angles from least to greatest. So again, this has to deal with the corresponding side. So this side is the smallest, so angle B is the smallest. This side is the next side, so this corresponds to angle C, so angle C is the middle angle. This is the longest side, so this is the largest angle. Some of y'all just told me these numbers in order. Give a range for all possible lengths of the third side if the first two sides are 31 and 28. So I talked about this in another problem too, but again, we know the range for the third side always has to be between the difference and the sum. And so I'm looking for the difference between 31 and 28. That's 3. And I'm looking for the sum between 31 and 28, which is 59. So I know our third side, x, has to be between 3 and 59. So this is how you write a range in math. This is not a range in math. This looks like a subtraction statement. Okay? A range uses inequality symbols to show the bounds of that range. Determine the side lengths could form a triangle. So again, we take the two smallest sides and we check to see if they are greater than the third side when we sum them. So 28 plus 22 equals 50. Is that greater than 50? So 50 is not greater than 50 because 50 is equal to 50. So this is a no, not a triangle. Okay. And the last one says, order the sides from least to greatest. So in order to order the sides, we need to be able to order the angles. And in order to order the angles, I need to know what all of the angles are. But right now, I only know 2 of the 3. But it's a good thing we know all triangles sum up to 180. So I'm going to figure out, what do these two add up to? 118 and 28. 6, 1, 3, 136. Did I do that wrong? No. Okay, and I want to know, okay, if I have 180 degrees in a triangle and I take away 136, then what am I left with? So I'm left with 44. So I know this angle is 44 degrees. Okay, and so now, again, the smallest angle corresponds to the smallest side. So I know our smallest side is HK. And then I look for the next smallest angle. The next smallest angle is 44, and that corresponds to KJ. And then I look at the longest side. The longest angle is 118, and so the longest side is HJ. Here, some of you just gave me the angles in order, so make sure you're reading the questions carefully.